This is Test Case Scenario with me, your host, Jason Baum. This podcast is the definitive hub for knowledge and stories in the software testing and development communities. If you're new to the channel, hit the subscribe button and let's dive straight into the episode. Hey everybody, welcome back to another episode of Test Case Scenario. I'm your host, Jason Baum, and with me, not as always, but a little more frequently again now, Evelyn Coleman. Evelyn.
Howdy. Happy to be back.
Yeah, super happy to have you back. Thank you. And we didn't really address this last time when you were on, but we're going to try and make this a more regular type thing of having you back, which we really appreciate your coming back.
I appreciate it too.
Awesome. And joining us today, we have a very special guest, Saurabh Shanbhag. Saurabh, thanks for coming on the show.
For sure. Thanks for having me. Nice to meet you, Jason and Evelyn. I'm super excited to be here. Thanks for having me again.
Yeah, awesome. Why don't you give a short introduction on who you are and where you're working, and then we can get right into the topic.
Of course. Yeah. I'm Saurabh Shanbhag. I work at DoorDash as a software engineer. I've been at DoorDash for a year now. Before that, I have worked at Amazon and Uber. All my experience as a software engineer. I live in San Francisco. I've been here throughout my career. This is the Silicon Valley hub for tech, right? So yeah, that's a bit about me.
Awesome. Yeah. So yeah, some good experience there, right? some small companies you might have heard of, Amazon, Uber, and DoorDash, just saying. So that's awesome. Thank you so much for being on and for giving us some time in your day to be able to have a conversation on Test Case Scenario. So we were chatting before the show and we were like, we could pretty much touch on any subject with you. And I think where we landed is we were kind of talking about catching bugs before they make it into production. And obviously everyone wants to do that. So we were going to try and give the listeners some takeaways that they can have in their back pocket. We were going to talk about the top 5 ways to ensure that your software system is reliable. Easier said than done, right? We want to make sure that it's built in a way that makes it easy to prevent the bugs before they take place. If everyone could do that, right, we'd be in a perfect bug-free world.
Yeah, something always slips through the cracks. But still, I think minimizing that number is the goal, right? And regardless of who you are in the company, like software engineer, QA, testers, managers, product managers, it's kind of everyone's job to make sure that the product is reliable. So I think at least in the companies I've worked at, it's pretty much a collaborative effort to make sure that the end goal that we launch is fully reliable and all spot checks are done by all people involved in the loop. I think that's the process that's prevalent, and there are multiple ways to address this before launching, multiple ways to test it, to poke holes in the system in a way, and design it better to start with, so that in the future there's not much back and forth.
So is it safe to say that at all the companies, because you've been at major enterprise level companies, is it safe to say that they've all gone through this cultural transformation where they've all shifted left and DevOps practices basically standard and everyone's kind of working together on this?
Right. Yeah. I think that's the trend at least. So for example, Uber and DoorDash are kind of smaller than Amazon, right? So Amazon has a more mature process of handling these things. The scale is also higher, right? So, and the impact of a bug is way higher. 5 minutes of downtime causes $1 million in losses probably. Whereas smaller companies have it a bit easier. So kind of the processes are less formal. They choose velocity over quality in some cases, which is also, there's no right or wrong, right? It's just a trade-off. So that's the key trend I see. But everyone at this point is adopting. Even DoorDash now is big enough that the focus is now on reliability. there are a lot of third party companies which just focus on helping other companies make their things reliable. A lot of that adoption is what I see into like adoption and focus into like making your product as reliable as possible.
When you say that the focus is, it's becoming more focused on this, are you saying it's more of like a laser towards the individuals who have maybe quality in their titles? Or is it a cultural shift where the focus is on making sure everybody understands that quality is everyone's job?
Yeah, it's kind of both. It's like those are two parallel streams, right? One is ensuring there are more people who are experts in like QA testing, like software SDDs, for example, like hiring more of these people so that we ensure that like there are no gaps in the design before we launch. And then like as software engineers as well, we go through a very formal review process right from the design, right? So in general, just to take a step back in the general process of like launching a feature or launching a product, the start is like with product teams come up with requirements, and like then engineers are in charge of designing the system and making it a reality. So before doing that, we go through a lot of iterations of like testing against production data that we have to ensure that it's feasible and it'll be a good product and a reliable feature. And then once we get the feasibility study in, we then start designing the system, the software system. And as we design and implement, we have a bunch of reviews with like senior and staff engineers across the org to make sure that this design has no issues with it. A lot of times, if we don't go through that review process, something will be missed. The engineers will build it and launch it. And then like when users users always find like edge cases. Like if we build a feature to do some task A, they'll kind of try using it for task B somehow. And we don't know why they're doing it, but that's a bug uncovered. So having these multiple review systems ensure that we think of all possible edge cases that can happen and tackle that in the design phase. But still, as I said, like something seeps through the cracks, and that's where the QAs and the testing teams come in. Like at least at the companies I've worked on, there's like a mix of automation and manual testing, where a lot of automated tests are run from software to QA both. So software engineers write unit tests, write integration tests, make sure everything in the software is covered. But still, there might be some weird case in which like on the UI you press one button and immediately press the next button and it doesn't work, for example. So that is handled by the QA manual engineers, which try to break the system as much as possible, try to do as unexpected things with it as possible to uncover potential bugs, and then that's filed against the software engineers again. And once we clean up all those bugs, that's when we think of launching it. And that's the process that we follow. So a lot of testing happens throughout. Like generally, it's like 50% development time, 50% testing time for software engineers.
Yeah. So specifically, at DoorDash or perhaps at Amazon or even Uber, how would you approach like system design and architecture to minimize the introduction of bugs from the start?
Great question. Yeah. So in general, it kind of depends on what the system is, right? But a lot of times the systems are made of like 3 or 4 main components. One is like the user interface layer, right? So there's like a different suite of testing for that. As I said, manual testers go through all button clicks, see if there's any latency anywhere. Like if I click a button and there's like 10 seconds that the page is just loading, then that's a problem, right? So all these things are on the interface layer, and then there's this backend API layer, if you will, where all the like system decisions of how after the click of the button, what processes should happen, if there's any potential bugs there. So again, for example, there might be one operation which takes like 10 seconds. So is there a way we can optimize it? Is there a way we can make sure that it doesn't time out and cause an error for the user? So we can make it asynchronous, like, and for example. And then that's the main software design. And then there's a database layer where there might be some issues in how we structure the database. For example, like just getting into one technical detail, if you don't add an index and then query for that thing, it might take way longer than it having an index. So some things like this is what the design process involves, where like you have to think through all these like multiple layers of the system and like try to ensure all these things are optimal. Because even if one, like a system is as strong as the weakest link, right? So we have to make sure that there is no weak link, and then we tackle all these things. And it's a collaborative effort. The designers are in charge of making sure there's no UI issues. The software engineers are in charge of making sure the backend system is robust. And then like the database managers or like the data teams are in charge of making sure that the data model is safe and secure.
That's awesome. From a bug prevention perspective, looking and designing across all of these layers, do you have to ever pause and consider sort of like future development down the road while you're doing this? And is there a part that plays into preventing bugs?
A very interesting question. So I've seen like different themes in different companies. For example, Amazon makes you think like 2 or 3 years in the future. So if, for example, you're building something, you have to kind of think of potential additions to that feature, potential like increase in the number of users for that feature, and like kind of solve for that to start with. And I think that's the right approach, but it sometimes goes into the realm of over engineering. So you don't want to spend like a year building something very futuristic and like lose time, right? So this trade-off is considered in these kind of smaller companies, I mean, not small, but like smaller than Amazon. Like at DoorDash, I see like that 2-year mark is more around like 6 months mark. So if we see that there are some product features that are going to involve some amendments to the feature I'm designing, I kind of will take them into consideration while I'm designing a system and make sure that all those future potential issues or additions are already solved in this initial design. But at the same time, I want to make sure that I'm shipping out the feature in a reasonable time frame. So I won't over engineer some features, if that makes sense.
No, that's a really good answer. Thank you so much. It's risk mitigation across all the people that we've talked to over the, can I say years now? Over the years, it's always such a balancing act, right? You don't want to over engineer, but you can't not think about the future. And doing both too much can also lead to bugs down the road. And I think it's just a parallel that we've had across everyone we've talked to, where there's not sort of a right answer. You know, we talk shift left, shift right. It's more about designing a process that fits for the size and scale that you're operating at and getting that sweet spot.
Exactly. I think like now, at least at DoorDash, we have hit that sweet spot where in the initial design stage, we kind of like enumerate anything and everything that can break in the future or that can be an addition in the future. Like it can be the most smallest, like unrealistic thing ever, but still we have to like enumerate it. We have to like write it in the design document and like write an explanation as to why we are not building that or why we are keeping that for later. As long as that's documented and like as long as you've thought about that scenario, you're good. That's good enough, right? Like then the reviewers can like think about that. And if someone says that this is actually an important thing to build right now and consider right now, then we'll do that. But you can't just like overlook things because you want to ship something fast. So that's a sweet spot, right? Where you don't have to over engineer and build everything, but you have to think of each and everything that can go wrong. And that kind of makes it safer to say that like, okay, I've built a reliable enough system and I can ship it. So I get the confidence and most likely it doesn't break because thought of the consequences of not building a feature and I'm okay with it, taking that trade-off.
Does everyone take that approach? Or is that something that it sounds really great, but in practice, does it actually happen? And the reason why I asked that is because we've actually asked that question to developers in a report that we do called Developers Behaving Badly, and then it's follow-up, developers still behaving badly. And it's not to like knock developers. It's actually the opposite. It's actually what we find is that developers are taking on more and more and more and more. Testing is one of those things. And so it's one of those things that's in theory, it sounds great, but in practice,
at least I do it. I hope my manager sees that. I'm kidding.
yeah. If your manager is watching, Saurabh does this.
Yeah, exactly. I do the ideal process, and I cause no bugs.
That's right. No
That's
bugs
amazing.
ever.
Yeah.
No one
Please
on
don't
the
cut this
podcast.
part. Please don't cut this part. Next thing I know, my manager is watching this and he's like, "What are you doing?"
That's awesome.
But
But bugs are going to happen, right? I mean, it's part of the process. It's what we're prioritizing, what signals we're actually paying attention to, pay attention to the red alert, right? I mean, that's
yeah. And the thing is, like, we at this point in the industry, it's so cross connected. Like, for example, DoorDash uses like APIs of like so many different companies under the hood for different things that any one of them goes down, which is not in our hand. Right? Take the Microsoft
I was just
situation,
going to
right?
say
Like, because of
CrowdStrike.
CrowdStrike, Microsoft systems had this issue. So you can never be like, I've covered all boxes and like I'm 100% safe, because it's such a cross-connected world at this point that any small piece, like for example, if AWS has an outage, half the tech industry stops, right? That's kind of why you can never say that like nothing will break, anything can break, anything unexpected can happen. But if something expected fails, then that's on you. So at least like the least that an engineer needs to do is to make sure anything that's expected to fail does not fail. If that happens, then like it's a problem in the design, right? Like that you didn't expect this to happen. Why didn't you? So I think at least like to answer your first question, the push at least in the industry is to go to that direction where you take full ownership as an engineer and like cover all these boxes. Of course, there are like sometimes you don't think of a certain scenario which can happen, right? And that's fine. Like we are trying to collaboratively build a safer system. So at least one thing I see in the industry throughout, and like especially at DoorDash, there's like a no blame culture. Like, even if it's a bug caused by an engineer, it's like a collaborative effort to fix it together and like make sure the system, like the outcome of the system, is reliable. And then we'd have some post-mortem process where we understand why this happened and how we can not repeat it.
Yeah, that's fantastic. And that's when it works, is when it's a true cultural transformation. That's a blameless culture. And that's the only way to move this thing forward in the right direction.
Exactly.
It's tough though, because, and yeah, exactly, bad things happen. But like zooming out a little bit, there's this struggle that's in this industry. That's been in this industry for a long time between, do we get it out fast or do we make sure that we're prioritizing quality? And you do have to pick one or the other. And a lot of times I hear, well, we're going to do both. But that's tough because but it's not true. It's right. It's just impossible.
Tough. It's impossible.
Right.
Yeah.
Right.
Unless you are good with like investing that much time and effort into building reliable systems, it's not going to happen, right? So I think it's also a factor of the scale of the company mainly. At least like if I'm tomorrow I'm starting my own startup, I'm just going to choose velocity, right? Like, for example, do you know the company levels.fyi? It's a company which basically crowdsources information about job offers and like which company's hiring, what's the compensation package and all. Okay. It's a pretty interesting tool for like software engineers who are looking for jobs. So it had like thousands of users and they had no software system. They used Google Sheets as the backend. Okay. No database, no nothing. That's the thing. So error prone, right? Someone goes and like updates that value and like your system is broken. But like that's the thing. Like if I'm starting my own company, I'll go for velocity. For sure.
High risk, high reward, right? I mean,
I want to bring in users and I want to ship out things faster so that like the users come in. But if there's a small bug which affects like 10 users, I'm going to take that hit because I want to ship fast. But now, like, there's a tipping point at some point, right? Like, and some indicators are like a lot of daily active users, or like company goes IPO, something like that. Like, those are kind of tipping factors where the focus then goes on making it more reliable. So you take that hit on velocity a bit, but you make sure that whatever you've built doesn't go down. Like, you cover all those gaps that you exposed when you were initially building it in a very quick way. You kind of cover those things, and then like in the future, whatever you build, you make sure that it's completely reliable. And it's a hard transition, to be honest. I think DoorDash is like now at the end point of that transition, where like initially they used like Python as the backend language, but this clearly saw that it wasn't scalable. So now they moved to Kotlin, which is like a way more scalable and better technology. And now we are like sunsetting the Python architecture. So that's a transition which most companies go through after that tipping point.
I can't help but think that the limitation between balancing sort of this velocity and quality is actually a good thing. Because if you could check both of those boxes, I was thinking about this, like, I feel like you would drive faster than your headlights. Like, if you could develop at top speed and do it with quality, you wouldn't have to slow down and get user feedback, and you might take your entire business in the wrong direction. So it's almost a blessing that we are limited how fast we can develop, and we do have this balance, because if you got your wish of having both, like, you'd always be limited by how quickly you can gather user data.
Correct. No, that's definitely true. That's kind of the trade-off of like company size and such as well, right? Because for example, if it's a smaller company, there's like a fail fast kind of ideology. Like, rather than building the right product, build the wrong product but ship it fast enough that you understand that that is the wrong product, and then you see what's wrong and fix it. And that's the best way to kind of get the market fit and all those insights from real customers. Because you might be biased, right? Like, you might think you're building the best product and you invest 3 years building it out, and then like nobody uses it. So rather than that, you push something in 3 months, see if people like it, see what people like, see what people don't like, and then like take that feedback, build it into the next iteration. And it's by design, right? Like, it's not that they're pushing out bugs, but they're seeing if this is a bug or not. When you hit that mark where you have enough scale, then it's also a point of trust, right? Now, if DoorDash has an outage, people lose trust in the company. So they might move to a competitor, for example. So the cost of that bug is so much higher now that we kind of want to invest time and effort. Even if it takes a bit longer, we want to make sure that we build a very reliant system.
So diving back in, we were up here, then we went down here, and then we went back up here. So diving back down, for DoorDash itself, at the scale that you're operating at, how do you integrate monitoring and observability in the development process to catch those bugs before they reach production?
Yeah, great question. So as I mentioned, we write this technical design doc, right? So that has like initial design stuff. So people can like think of things that can fail, and we factor it into the initial design. But then there's also a document we write, which is called the production readiness review. Okay. So that basically has like a checklist of items that we need to build. Just to touch on a couple of points in that document is the alerting. So if the feature is down, what are the thresholds at which we want to alert the on-call engineer? Just so everyone knows, like almost all software companies and all software teams have this on-call process. Like for DoorDash, for example, is used in multiple countries across the world. So at any time in the middle of the night, there's still traffic on the service. So if something goes down, someone needs to come in and fix it. So 24/7, some engineer has the job to be on call, and they have like a PagerDuty app or some similar paging app, which the alerts get routed to. So before we launch any feature, we add alerts. So if, for example, the error rate goes above some percentage, we send an alert, and then the on-call engineer has to investigate that. So that is an unnecessary thing to launch. We also create a bunch of dashboards to ensure that the success criteria of the feature is being met. Like, for example, if I'm building like a checkout page, for example, then I need to understand that the errors are very low, the latency is very low. Like, I don't want them to wait for a minute before the page loads, right? Or get timed out and like get error screens. So we have graphs monitoring that and like alerting on spikes. All these dashboards and alerts are needed to be enumerated and made sure that those are functional. And then there are some testing checkboxes. So like couple of things are like full coverage in unit tests, full coverage in integration tests. So automated integration tests, wherein you call your own service for different scenarios and make sure that the expected outcome is what it's returning. And we can't launch unless all these tests pass. And like in the future, when I iterate on a design and some prior test fails, that's an indicator that okay, something broke, so I have to go back and fix it. Like we have to check these boxes for testing, and then for some features which touch the user interface also, that we have like manual QA testing. So QAs can then go through the flow, try to break the system, and then like they create tickets for us, wherein like the expected and the actual output is shown like screenshots maybe, and then we kind of investigate why that's happening and fix that before launch. And the launch process is also very like incremental. Like we use a lot of experimentation, where like we use A/B tests. Like we roll out the feature to 50% of the users for like a month, and then we see if there are any issues with those users, if they are interacting any different, or if there's enough value for those 50% users where we have rolled out the feature to. So that's how we kind of monitor the effectiveness of a new feature that we are building. And that again, the experimentation plan is also part of the document that we write before launching. And just to be safe, we launch it to 1% first and make sure that those requests like manually go in the logs and see if those requests are performing as expected. Because if there's a bug, like I'll see that the 1% requests are failing and I'll just roll it back. I'll fix that bug and then go back and launch it to 1%. And then we go to 10%. Then we go to 25%. And then we wait there because now there's enough traffic where some metrics can get tripped. Like for example, something might work for 5 users, but when I scale it to 100 users, it fails. So we stay there for some time to make sure that it's doing well. Meanwhile, we gather metrics to see if everything is on track. And then eventually, once all these things are good, we launch it to 100% and call it done. At the same time, these alerts tests are always running in the background. So anything breaks at any point, we get paged. We have the ability to roll back the feature. Like it's handled by feature flags. So I can just kill a feature with a click of a button to make sure that the experience is preserved for users. Then I'll go back and like examine the logs and check what's wrong. So that's a process we build. As I mentioned, like there's a lot of things that we do, right, to make sure that no issues are surfaced in prod and still things fail. So we have a robust enough system to kind of track them and mitigate the issues very quickly if and when they happen.
Awesome. We're coming up against time, so now I want to do like a lightning round, if it's okay with both
sure.
of you.
Yeah.
I want to provide a top 5 ways to ensure your software system is reliable. So why don't we go to you, Saurabh, first, and then we'll go back and forth.
Yeah, I mean,
these are guests. These are guests, Evelyn.
No,
We'll
I
have your
meant
chance.
you're not going like round robin, right? Like they're all
Oh
gonna
yeah,
have
I'm gonna
first
make
drop.
you. I'm gonna make you. No, you don't want to do
It's
it.
fine. I'll come up with something.
Yeah, you can do it. I'll take one too. All right, go. Let's
Okay.
start with you, Saurabh.
Yeah. So first and foremost, I think to build a reliant system, the design needs to be thorough enough. So investing more time in the design phase, poking holes in the system, is far better than shipping something with bugs and then putting band-aids on top, right? So initial design is the main thing. So focus more on poking holes initially and build a reliant design.
Awesome, Evelyn. 2.
Oh, I'm going to take an easy one. Building a quality assurance culture throughout the entire software development lifecycle. So it's everyone's responsibility to make sure that the product doesn't have bugs in the end.
Awesome. I'll go 3. Comprehensive testing at every level. Comprehensive testing at every level that is continuous. Saurabh.
Yeah. So, like as we discussed, like bugs still happen, things still break. So having a very reliable mitigation system, mitigation process, mainly like building thorough alerting and metric reporting, and then like writing good run books and stuff, because that's also reliability, right? Like it's not that you don't fail, but like how fast can you bring the service back up? So having a thorough process for that is also a great aspect of it.
All right. Number 5, Evelyn, take us home.
Oh my goodness. Not just relying on one method of testing. So like Saurabh said, they have manual testers and automated testers and good unit coverage and also third-party tools that are looking through the software. So kind of spreading the load.
Beautiful. And there we have it. Thank you. Thank you so much, Saurabh. Thank you, Evelyn. And thank you for listening. We have had a lot of fun on this episode. This is a good one. I really appreciate you coming on, both of you, actually, and would love to do this again sometime. So please come back and don't be a stranger. And thank you so much for spending time with us. We will see you again on another test case scenario. Thank you for joining us on Test Case Scenario. Share your thoughts in the comments. We'll make sure to respond to each and every single one. Don't forget to subscribe and hit that notification bell to keep in touch. If you missed our last episode, it's popping up on your screen right now. Go, click it. Until next time on Test Case Scenario.